And let me grab my notes so that I can find them. That's not us. That's a different class. Where are we? Here we go. Boom, right here, y'all. Okay, so y'all, when we were here last Thursday, this was the last problem we had done. We had done this question about the babies and how long are babies and all that kind of stuff when they're newly born. Okay, y'all, what we're gonna do this afternoon, 5.3, we're gonna find z scores. So one of the things that we did in 5.1 was if we knew what the z value was, we could find the area to the left of it, or we could find the area to the right of it. What we're doing now, y'all, we're going to be going backwards. We know what the area is, and what we're going to try to do, y'all, we're going to try to figure out what is the z value that corresponds to that area. Okay. So, y'all, one thing I want to mention is that when I'm using my table is always going to tell me the area, y'all, to the left of my graph. Okay. So y'all, I'm going to show you two ways to do this kind of a problem. The first thing I'm going to do, y'all, I'm going to come back over here to my info. Let me see, week 7. Let me do this. Let me open this up. And y'all, first thing I'm going to do, I'm going to look at that table, the same table we've been looking at so far. Okay. So y'all, I want you to notice something here. They're telling me that the area to the left of my curve is 0.1515. And we're trying to figure out what the z value is. Okay. So y'all, one way we can do that, y'all, is we can use our table. And y'all, what I'm going to do here is I'm going to scroll through my table and I'm going to see, hey, can I find a 0.1515 anywhere? So let's see, 0.1515. Let me see. Boom. I see it right here. Guys, do you see what I'm talking about? Here's that 0.1515. So y'all, if I wanted to find out what my z-score would be, right? So y'all, what I could do, again, I'm just looking at my table here, y'all. I'm looking at the first page of it. Here's my 0.1515, right? I kind of have to search for it. It's not the easiest thing to do. It's not also the hardest thing to do, but I'm kind of just looking at my table here. And if I see this 0.1515 right here, y'all, the z-score that we would have would be negative 1.0 when we go up. 1.03, right? So we could come back here and we could say, hey, look, our z value is negative 1.03, right? That's one way we can do it, okay? Is it difficult to do? Not really. I mean, you kind of have to look around for a bit. It's a little bit of a hunt, right? But it's not the hardest thing to do. Now, obviously, guys, we have our calculators, and our calculators can show us how to do this as well. And because we're using the standard normal distribution, y'all, what we're going to do on our calculators, we're going to look for this feature called the inverse norm, okay? And when we do the inverse norm, y'all, let me just kind of give you some information here. When we do the inverse norm, what we're going to put in here, y'all, is going to be the area to the left, okay? So y'all, let me show you how we're going to use this on our calculator. Okay, again, one way is the chart. For those people who like the chart, we know how to do it. The way we're going to find our inverse norm, y'all, we're going to come back to our calculator. Let me open this guy up. And just like we've been doing before, let me clear everything. Y'all, we're going to go to second and we're going to go to vars. And I want you to look at number 3. Number 3 is telling me the inverse norm, at least on my calculator. Y'all, I know on some of the apps it might be a little bit different, but again, you're going to go second vars and you're going to look for this one here that says inverse norm. So I'm going to hit number 3. And remember, my friends, what we're entering in is the area to the left. So the area to the left, y'all, is 0.1515, right? And we're going to come back here. We're going to close off our parentheses. And y'all, again, if we round to 2 decimal places, negative 1.03, right? Yes, sir.
Or is the sigma still going to be 1 and then our
Yeah, everything else is going to be the same. All you're entering in is just the area to the left. You're not changing anything else. So your average, the mu should still be 0, and the standard deviation should still be 1. Okay, yeah. So y'all, again, this is just a second way to do it. And again, I think for most of us, the calculator was probably the easier approach. So this is what we're going to be using. Okay, again, y'all, if you want to use the table, by all means, you can use the table. I think personally the calculator is easier, right? I'm not having to hunt around, but again, it's up to you. Okay, so y'all, I'm going to do the same thing for question number 2. And I want y'all to look at question number 2. Now, y'all, one of the things that we talked about with our standard normal curve is that the curve is symmetric. What I mean by symmetric, y'all, is like this morning when you were getting ready to come to school for your other classes you had before this one. And if you're looking in the mirror before you leave the house and you're standing, say, 4 feet away from the mirror, your reflection looks like it's 4 feet back that way, right? And that's the same thing that's kind of going on with our curve here, right? Here's kind of like my mirror line. If we know what this line is, we can figure out what that value is going to be as well. So y'all, remember, the first thing I'm going to do is I'm going to come back over here. I'm going to use my inverse norm. Okay. Remember, y'all, we're always going to enter the area to the left. Okay. So we're going to go, oops. We're going to come back here. We're going to go inverse norm. And the area to the left, y'all, looks like it's a 0.0314, right? So, y'all, I'm going to do the same thing here. Second vars, number 3.0314. Again, I'm not changing anything else. I'm going to hit enter. And is anybody coming up with a negative 1.86? Okay, so look, y'all, we found this value, negative 1.86. Because our graph is symmetric, does anybody think they would know what that value would be? Very good. Awesome. Positive 1.86. And you're just like, hey, how do you know that? Because again, if from this way, that way, that's negative 1.86, that one has to be positive 1.86, right? So again, y'all, as I'm doing this here, I'm going to kind of reason like, hey, if I know the value on the left, we can find the value on the right, right? It's just going to be the positive of that number. Okay. Okay, guys, I'm going to scroll down a little bit further. And we're going to do the same thing for this next question. We're trying to find those Z values. Now, remember, y'all, one thing I want to mention is that when we're doing our inverse norm, okay, we're always going to be entering in, y'all, the area to the left, okay? So, y'all, one thing I'll just as a quick reminder, when we have our standard normal curve that kind of looks like this, okay? I'm just drawing, again, a very rough picture. Remember, y'all, the total area is equal to 1, right? So, y'all, if the total area is equal to 1, what do you guys think the total area of all this would be? Very good. 0.5, right? We know that that area would be 0.5, okay? Half of it. Now, y'all, what we're really trying to figure out is can we find, let's do it like this, just so that everybody knows that's the area that's 0.5. But y'all, what we're really trying to find is what would that area be? Is there a way we can figure out what that area is? If we know the whole thing is 0.5, and we know that this area here is 0.46, does that say 4686? It's hard for me to see. It looks like it's 80. 86? Okay. So if we know that that's 0.4686, how do you guys think we could figure out what that area would be? Subtracted, right? Very good. Let's do that, y'all. Let's come back here. Let's take 0.5 minus 0.4686, okay? And so, y'all, that area there would be 0.0314, okay? So again, y'all, if we're going to find that area to the left, we're going to come back. We're going to go, hey, let's use our inverse norm, and we're going to enter in 0.0314. So, y'all, I'll just grab my calculator. Hey, we did that already, didn't we? Was that the one we just did? 0.0314. So, y'all, the value we came up with was a negative 1.86, right? And again, just like we did before, y'all, if this value right here is negative 1.86, what did we say that value would be? A positive 1.86, right? So, again, y'all, one thing I want to mention, right? it's not going to be necessarily super hard to do. What we got to figure out, y'all, is, or just remind ourselves that my calculator, my table is always going to be able to do this, but it's talking about the area to the left. So if I know the area to the right, I can find the area to the left, and I'm going to have to do that. That's going to kind of be my goal here, okay? All right, y'all, let's scroll down. A big part of 5.3, y'all, is this is going to be it. There's going to be a couple extra problems we'll figure out in a second, but this is going to be a huge part of what we're going to do, okay? And again, y'all, it's just to kind of get you comfortable with using the calculator and understanding how we can find these values. So look, y'all, the next question says, find the z-score for which 75% of the distribution's area lies between z and negative z. The first thing I'm going to do here, my friends, I'm going to draw a picture, okay? I'm going to draw my standard normal curve, okay? I want you to notice something. They're telling us that we're going to find two values. One of them is going to be a positive and one's going to be a negative. So why don't we do this? Look, right here, negative z, and right here, positive z. And they're telling us that the area lies between those two values. So y'all, they're telling me the area in here, okay, in that middle piece. So y'all, the area here is 75%. Does everybody agree as a decimal, 75% would be 0.75? Okay, so look, y'all, right here, we're going to put a 0.75. We know that's what the area is over there, okay? Now, remember what we said, y'all. The total area, right? The total area is going to be equal to 1. So if we wanted to find out what would the area be here and what would the area be there, we could find that. We could say, let's take 1 minus 0.75, and that would give me 0.25, right? Like if I had $1 and I took away 75 cents, I got 25 cents. But y'all, that is the area in both those light blue areas. How could we find, say, the area just in this part, boom, right there? If the area in both blue parts is 0.25, what do you think we need to do to find the area here and find the area there? Divide it by 2, right? Isn't that 0.25 going to be distributed over those two pieces? So why don't we do this, y'all? Why don't we take our calculator and go 0.25, let's divide it by 2, and right here, y'all, we got a 0.125. Okay, am I making sense? We're doing okay so far? All right, y'all, let's do this. Let's go ahead and use our calculator. We're going to go inverse norm. And the area to the left, we just said was a 0.125. So y'all, I'm going to grab my calculator right here. Let me turn this guy on. Let me clear it out. Let's go second bars. We're going to go to number 3, inverse norm. And we said that area to the left, y'all, is a 0.125. We're going to hit enter. And y'all, our negative value is end up being a negative 1.15. What do you think the positive value will be? Positive 1.15, right? Boom. And there you go. Excellent. Very good, very good. All righty. Y'all, my next question actually has 3 parts. Y'all, the way I'm going to do these 3 parts, I'm going to draw pictures for each of them, okay? So look, y'all, I'm going to do my part A like this. Here's my standard normal curve. This little P8, that just means it's the percentile. And the first one, when it says P8, means 8%. So y'all, I want you to think about something. 8% as a decimal would be 0.08. So what they're telling me is that the area over here, y'all, is a 0.08. And we want to see if we can find the z-score for that, okay? So y'all, what I'm going to do is I'm going to grab my calculator again. I'm going to come back to my second and my bars, right? I'm going to go to my inverse norm, number 3, and the area to the left is 0.08, right? Why 0.8? Because it's 8%. And as a decimal, 8% is 0.08. And y'all, I'm coming up. If we were to go to 2 decimal places, negative 1.40 or 41? 41. Very good. Negative 1.41. Look, y'all, let's do part B. We're going to do the same thing in part B. Okay. So right here, y'all, 25% as a decimal, that's 0.25. We're going to look for our Z value. Okay. So y'all, we're going to do the same thing we did. Come back here, inverse norm, change that 0.08 to a 0.25. Let's hit enter. Negative 0.67. Okay, negative 0.67. And y'all, I got one last one to do like this. Here's my graph. Boom. Now look at the area now, 0.95, right? If it's 95%, y'all, aren't we going to be looking for all this business? 0.95. We want to find, hey, what is that Z-score going to be? So again, y'all, I'm going to come back here, do exactly the same thing, except now we're looking at 95% of the area. We're going to hit enter and 1.64? Okay. Now, y'all, one thing I want to mention. Remember, my friends, in all these problems, the middle value here is 0, right? The middle value here, sorry, it's a little messy, is 0. So y'all, when I look at my first picture and I look at the area we're trying to find, 8%, that's way to the left. To me, it makes sense that my Z value is negative. Why? Because I'm on the left side of 0, right? Same thing over here. Look, 0.25, right? We're right between 0 and the end. Again, my Z value also being negative. When it was 95%, we were way over here. So again, when we got a positive number, it makes sense to me. Does that make sense on how we're able to figure that out? So again, y'all, when I think about those kinds of things, when I get my answer, look, I'm going to trust my calculator because it's doing something like the inverse norm. What is my calculator really doing, y'all? It's really going back to that table and it's finding that percent wherever it happens to be. That's really what my calculator is doing for us, right? It's searching for that number that we were trying to find, okay? So I'm going to trust my calculator, but I'm also going to trust my instincts. So like, hey, if it's a negative, yeah, that makes sense. Or like over here, it's positive. Yeah, that makes sense to me. Okay. Y'all, we got a couple more like this, and then we'll do something hopefully a little bit more interesting. Okay. A Z-score that has 11.7% of the distribution's area to the left. Let's draw a picture. Boom. Here we go. 11.7 as a decimal, my friends, is 0.117. So we're going to go right here. We're going to say that area is 0.117. What do you guys think? Should the Z value be positive or negative? Negative, right? Because we would know that if it was at 0.5, it would be 0. So since it's smaller than that, it's going to have to be a negative number, right? Awesome, guys. Let's go like this. Second inverse norm. 117, hit enter. There you go, negative 1.19, right? So we're kind of getting like, yeah, this seems like this is going to be right. Because again, we know that we were to the left, we should be getting a negative answer, right? Okay, now, y'all, look at my next question. Again, same thing here. Find a Z-score that has 74.2% of the distribution's area to the right. Okay, so let's look at this picture. Y'all, if the area is 74.2%, which is the same thing as 0.742, but look what they're telling me. That's the area to the right. So look, y'all, this area here is 0.742. Remember, my calculator and my table will only tell me the area or only find that Z-score when I know the area to the left. Does anybody know how could we find this area? 1 minus, right? So let's go like this. 1 minus 0.742, very good. So this area here, y'all, is a 0.258, right? And we're going to come back one more time. We're going to go second bars. We're going to enter in our numbers, which is a 2, a 5, and an 8. We're going to close that off. We're going to hit enter. And what do you guys think? Negative 0.64 or 5? 5, right? Good, y'all. Boom, there we go.
Sir,
Yes.
even when you put, if you do the same thing the norm, and you put 0.742,
Uh-huh.
it gives you the same answer.
Does it give you the same answer, or does it give you the positive of that
It gives
answer?
you the positive.
It gives you the positive of that answer, right? So y'all, what he's saying is, look, if we were to do this, right, and we know that the area this way is 0.742, but if we would have done this, and if we would have said, look, 0.742, this would have given us a 0.65, right? But because, again, y'all, the graph is symmetric, remember, you could flip it around. Does that make sense? And if you flipped it around, wouldn't that 0.65 become a, right now it's positive, it would become a what? A negative, right? Yeah, that's sort of the idea. All right. So yeah, these are good things, y'all, because we're able to figure stuff out as we're going through it. So look, y'all, I got one more problem like this. Again, just trying to get everybody comfortable with how to use the inverse norm, and then we'll get into some, hopefully something a little bit more interesting here, okay? So look, y'all, first thing I'm gonna do, draw my picture. Y'all, I wanna mention something. With chapter 5, for the most part, I'm gonna be drawing these pictures a whole lot, okay? And look what they're telling me. 97% of the area lies between these two numbers. So we're gonna have a negative z, we're gonna have a positive z. The area here is 0.97. And y'all, I think we did one just like this a few minutes ago. We're going to try to find, boom, those areas, right? So remember, since the total area is 1, if we do 1 minus 0.97, we should get something like 0.03. But that 0.03 is telling me all of the purple, both purples. Bless you. If we wanted to find this area right here, couldn't we take 0.03 and cut it in half to get a 0.015? And now we can find what that z-score is going to be, right? Okay, so let's do this, y'all. Second vars, inverse norm, 0.015. Let's close that off. Let's hit enter. And y'all, I'm coming up with a negative 2.17. And so the other one should be a positive 2.17, right? All right. So y'all, again, that's just some like basic skills so that we can figure out how to do some of the things we're going to be talking about here, okay? So let's do this, y'all. The other thing we're going to talk about today, y'all, is how do we transform a z-score to an x value? So when we were here on Thursday last week and we had all those problems and we said, look, it's a normal distribution. Let's convert it to the standard normal distribution. So we convert everything to z-scores and then we found the probabilities. What we're going to be doing now is if we know the z-score, let's see if we can go backwards and find the x value. Okay. So y'all, we got a formula here. And the way we find this formula is x equals mu plus z times sigma. Okay. So remember, mu is my mean. Well, we should have a z-score. They should give us a z-score, and sigma is going to be my standard deviation. Okay. Y'all, one thing I want to mention here, in this particular problem, when they phrase it like this, what they're telling me, the first number is my average, and the second number is going to be my standard deviation. Okay. So it says, look, the normal model, N5821, all that's telling me is that my average is 58, and my standard deviation is 21. Describes the distribution of the weights of chicken eggs in grams. Hey, chicken eggs is a popular topic today, isn't it?
Yes, sir.
All right. Suppose that the weight of a randomly selected chicken egg has a z-score of 1.78. What is the weight of the egg in grams? And then they're asking us to round to the nearest hundredth of a gram. Okay, so look, y'all, let's do this. We know what our average is. We know what our standard deviation is. They just told us that the z-score was a 1.78. What we want to find, y'all, we want to find the value of x, which is talking about the weight of the egg in grams, okay? So y'all, what I'm going to do is I'm going to come back and I'm going to use this formula. X equals mu plus z times sigma. And all we're going to do, my friends, we're going to plug and chug. So we're going to take our average, which we said was 58, plus we're going to use our z-score, which they gave us to be 1.78, times our standard deviation of 21. Okay, y'all, just like the way I wrote it here is exactly how I'm going to enter this in to my calculator, okay? So look, let me move this out of the way. Let me clear everything out. The first thing I see is 58 plus 1.78. And then right next door to that, y'all, we're going to drop our 21. And there we go. So a chicken egg, that z-score, y'all, has a weight of 95.38 grams. And we found the weight of that chicken egg. All righty. Y'all, I'm going to scroll down to problem number 7, and we're going to see if we can figure out what's going on here. Let's take a look at number 7, y'all. It says the amount of rainfall in January in a certain city is normally distributed with an average of 3.8 inches and a standard deviation of 0.4. Okay. Find the value of the 25th percentile rounded to the nearest tenth. Okay, so y'all, we did this a minute ago. Let me draw my picture. Okay, here's my picture. Remember, the value of the 25th percentile, y'all, just means we're trying to find the area to the left, or we're trying to find the z-score, I'm sorry, when the area to the left is 0.25, okay? Let's see if we can find that z-score. So remember, y'all, the way we're going to do this, we're going to go inverse norm of 0.25, okay? So let me do this. Let me clear this thing out. Let's come back second bars. Let's go to number 3, inverse norm. Let's go to 0.25. Let's close that off. And y'all, the z-score we're getting is a negative 0.67, okay? Here's our z-score, okay? Okay, what we're trying to do, y'all, is we're trying to find the x value. How much rain is going to correspond to a z-score of negative 0.67, okay? Y'all, the first thing I'm going to do, I'm going to write down my formula again. This is just the formula and how we convert a z-score backwards to an x value. This will tell us how much rain we're going to be getting, okay? So look, y'all, we're going to come back here. We're going to say our mu, in this case, remember, guys, my mu is the average of 3.8. My standard deviation is 0.4. So we're going to go 3.8 times 0.4 times a negative 0.67, okay? So y'all, just like the way I wrote it out here is exactly what I'm going to type in on my calculator, okay? So look, 3.8 plus 0.4 times our z-score of a negative 0.67. And let's hit enter. And y'all, they're telling me to round to the nearest tenth. The nearest tenth, y'all, is going to be 1 decimal place. So would you guys say 3.5 or 3.6? Sorry, come back. What do you guys think?
Should the 0.4 have gone with negative 62? Since 0.4 is the standard deviation.
That's what we did, right? So 3.8 plus our sigma right here, which was 0.4.
times.
Oh, okay. Yeah, yes. Well, it's
Does it matter?
do it. Nah, it didn't really. Okay, Z. Yeah, it didn't matter. I'm sorry. I wrote it wrong, but it didn't really matter. And so, guys, let me just tell you something here. I wrote what did I write? Sigma C or Sigma Z, and it's Z sigma. You know why it didn't make any difference, y'all? Because we're multiplying. And remember, when you multiply, what number you put first, what number you put second, doesn't make any difference, right? Okay, yeah, I see what you're saying. So here, guys, I'm coming up with what, 3.5? Yeah. So it's 3.5 inches of rain, right? That's all they're asking us to find. Okay. That's all really they're asking us to find. Good questions, guys. Good questions. Yeah. So, and the reason why we had to do that was because, see how they told me find the value of the 25th percentile? That's kind of like when we did these problems right here, where we found the Z value. And then now we have our Z value, we can go back and find what the X value is going to be. Yeah. So, y'all, I got a couple more questions here out of 5.3 for us to figure out. And the weights of newborn hippopotami, did y'all know that's the plural of hippopotamus? Hippopotami is approximately normal with a mean of 87 pounds. Okay, y'all, I'm going to stop right there. My average is 87. My standard deviation is 11. Okay. Okay, let's see if we can figure out part A. Excuse me, part A says, what's the probability, that a newborn hippo weighs between 90 and 111 pounds? Yo, this is what we did on Thursday last week. We're looking for the probability that the hippopotamus or the newborn hippo weighs between 90 and 111. So remember, my friends, in order for me to do this, I need to find two Z values, okay? We're going to find Z1 and we're going to find Z2, okay? So y'all, in order for us to do this, I'm going to write down my formula for my Z score, okay? It's the same formula we used, y'all, in 5.2, okay? But let's do this. Let's find the probability for Z1, okay? Y'all, I'm going to say this is going to be the first value we're going to use. This is going to be our first value for X. So we're going to say 90 minus our average of 87 divided by 11. Okay. So 90 minus 87 is 3 divided by 11. Y'all, 2 points. All right. Okay. Let's find our second Z value, y'all. We're going to use the same formula, but now we're going to go 111 minus 87 divided by 11. Okay. 111 minus 87 divided by 11. 2.18. Okay. Okay, 2.18. Okay, now, y'all, what we want to do is we want to find the probability that our Z value is between 0.27 and 2.18, right? So let's do it like this, y'all. Sorry. Remember what we're looking for. Here's my thing, right? This one is a 0.27. This is a 2.18. We're looking for that area, right? Y'all, can't we do our normal CDF? And we know our lower limit and our upper limit, right? So we're going to go normal CDF, 0.27, and then 2.18. Let's clear this out. Second vars, let's go to number 2, 0.27, comma, 2.18, because we're looking for that probability, right? We're looking for that area in the middle. And y'all, right here, I'm coming up with 0.37895, and I'm going to look to see what my directions are telling me. Y'all, in this problem, they're telling me to go to 3 decimal places. Y'all, would you say 0.378 or 379? 379. So right here, y'all, we're going to write a 0.379. Okay. And that's what our probability is. Okay. Okay. Now, let's take a look at part B, y'all, because we got a part B here. A weight of how many pounds corresponds to the 5th percentile for newborn hippos? Okay, let me think about what's happening here, y'all. I'm going to draw a picture. Here's my picture. If they're talking about the 5th percentile, remember what that means, y'all? That the area over there to the left is a 0.05. Let's see if we can find that Z value, okay? Y'all, if the area to the left is a 0.05, remember how we're going to find the Z value? We're going to come back to our calculator. We're going to go second bars. We're going to go to our number 3 to find our inverse norm so we can find that Z value. We know the area to the left is a 0.05. So y'all, for my Z value, I'm coming up with a negative 1.64. Okay. Negative. Okay. But we are trying to find the weight, my friends. We're trying to find the weight in pounds. What that means, y'all, is we want to find the X value. Okay. So let's use the formula for that. Okay. So guys, remember what I'm going to do. I'm going to come back over here, right? We know our mean and our standard deviation. Let's see if we can find what we got here. Okay, mu 87 plus Z. We just came up with a negative 1.64 times our standard deviation of 11. And y'all, I'm glad Baldo asked this earlier. Remember, the order in which you put those, y'all, doesn't matter because you're multiplying them, right? Let's see if we can figure this out. So let me grab my calculator. Let's come back over here. 87 plus, and I'm just going to drop some parentheses here, negative 1.64 times, what, 11? And let's go like that. 68.9? Yeah, 8.96. Y'all, they are asking me to round to the nearest integer. So when they're asking me to round the nearest integer, they want me to round to the nearest whole number. Would you guys say 68 pounds or 69 pounds? 69 pounds. Okay. So y'all, right? 69 pounds. Okay. So y'all, remember what the average weight of a newborn hippopotami was? It was 87 pounds. So in the 5th percentile, they got to be pretty small. 69 is pretty small, right? Compared to 87, I mean, it's almost 20 pounds less. So it's got to be pretty small, right? Okay, part C, y'all, says the percentage of hippos born weighing 26 pounds or less. That's really tiny, okay? Let's see if we can do this, y'all. Let's come back here. Probability that our hippo weighs less than 26 pounds, okay? Y'all, just like we did before, we're going to convert our X value to a Z-score. Here's my formula for the Z-score. X minus mu over sigma, okay? Our X value, 26. Our mu value, 87, divided by our standard deviation of 11, okay? So let me grab my calculator here. Boom. 26 minus 87, and then divided by, what, 11? Negative 5.55. Is anybody else getting that same number? Right? So negative 5.55. Right? Okay, now remember, y'all, I'm going to come back here. Sorry, I should have given you some more space, or at least I needed more space. Okay. We're looking for the probability that Z is smaller than that number. Okay. So look, y'all, way over here, negative 5.55. And I'm looking, y'all, for the area to the left, right? Trying to find that probability, okay? Y'all remember, we're going to go normal, CDF. If we are all the way over here, y'all, to the left, what number did we use when we were all the way to the left? Anybody remember? Negative what, though? Negative 500, negative 5,000, whatever we want to do, right? And then we're going to stop at a negative point or negative 5.55, right? Okay, so look, let's try this, y'all. Let's go second bars. Let's go to our normal CDF. We said all the way to the left was negative 5,000, comma, negative 5.55, okay? And y'all, look what happens when we hit enter. 1.43, and we have that negative 8, okay? Do y'all remember what that meant? We were going to move this decimal point 8 spaces. Which way? To the right or to the left? To the left. Okay, so y'all, if we were going to move this decimal point 8 spaces to the left, 8 spaces, that's a lot of spaces, right? Wouldn't we have something like this? Point 1, 2, 3, 4, 5, 6, 7, and then 1 and whatever else we got, 143, right? Okay. All right. Okay, so look, there's my answer, right? Because it's a really, really small number. Y'all remember, if we wanted to convert this to a percent, what we'd have to do now is we'd have to take our decimal and move it 2 spaces over, okay? So now, if we had 0.00, let me see, 1, 2, 3, 4, 5, 3, 4, 5, 143, what percent would that basically be? Let me ask you that. What number does this look really close to? Does that number look really close to 2? Does that number look really close to 7? Does it look really close to 0? What do you all think? 0, close to 0, right? So what percent are we going to get? 0%, right? Why 0%? Because that number is so ridiculously small, right? 0.00. There's like 5 zeros before you get to something that's not 0. Okay. So remember what we said, y'all. The hippopotami were weighing about 87 pounds. What's the probability that we're going to find a hippopotamus that's weighing 26? Not very high at all, right? Right? Why not very high? Because they all average about 87 pounds, right? 26 pounds. I mean, that's pretty small compared to the average, right? Okay. Y'all, we got a couple more questions to do, and then we will be done, my friends, with 5.3. Y'all, one thing I want to mention here in 5.3, there's a couple of things we're doing. If they're giving us a percentile or a certain area, we need to find the z-value by doing the inverse norm, okay? If we know the z-value, we're usually going to have to try to find what the x value is associated with that, okay? So let's take a look at the next question. I'm going to try to go slow, y'all, make sure that all this stuff is making sense. Scores on an exam required for all medical school applicants were approximately normal, with a mean score of 498 and a standard deviation 9.3. Okay, guys, number one, do you guys agree that we can write our mu is 498 and our standard deviation is 9.3? Okay, we know that already, right? That's pretty good because we at least know that part. Okay, now it says, suppose that an applicant had a score of 511. What percentile corresponds to this score? Okay, so y'all, what we want to do here is we want to say, look, the average was 498. Somebody got a score of 511. We're trying to find that area. That's what the percentile means. The percentile tells me the area to the left. Okay, so if we want to find what that area is, what we're going to do is we're going to change that 511 from an x value to a z-score. Okay. Okay, so let's do that. In this case, my friends, our x value, 511, minus our z-score of 498, divided by 9.3. Yeah, we're going to round it to 2 decimal places. With the z-scores, y'all, excellent question. Y'all, with the z-scores, we're always going to round to 2 decimal places, okay? What do you guys think? 1.39 or 1.40? 1.40. Okay. What we're doing now, y'all, here's 0. Here's z equals 1.4. We're looking for the area to the left, okay? Look, y'all. Normal CDF, okay? If we are all the way to the left, anybody remember what number we said we used? Excellent, negative 5,000. Where did we stop at? Sorry, I wrote real messy here. Didn't we stop at 1.40? Okay. Let's do that. Okay. Let's come back over here. Let's turn this guy on. Let's go second bars. Let's go to our normal CDF. Negative 5,000, 1, 2, 3, comma, 1.40. There we go. Okay, so the percentile, y'all, and I want you to notice something here, y'all. They're asking me to round this to the nearest integer. So guys, think about it this way. If we had 0.919, everybody agree? 91.9%? Okay, but since they're asking us to round to the nearest integer, they're just saying, can you go to the nearest whole number? Would you guys say 91 or 92? 92. Boom, 92%. Okay. Oh, man.
So these problems are always going to require a two-step.
A lot of them are going to be two-step problems. Yeah. A lot of them are going to be two-step problems, right? So like in this one, because they were looking for the percentile, that means they were looking for the area, right? What's the percentage we're going to get? So we converted it to a z-score so we could use our normal CDF, right? Now, guys, look at part B. Part B says to be considered at a highly selective school, an applicant should score in the top 12%. Okay, guys, I'm going to stop right there. I'm going to draw a picture. The top 12%, would that be the area to the left or would that be the area to the right if it's in the top 12%? To the right, right? So look, y'all, the area here would be 0.12. But I want to remind you something. My calculator only knows how to do the area to the left. Anybody know what the area over here would be? How could we find that area?
-1?
Yeah, there you go. So look, guys, let's go 1 minus 0.12, 0.88. Okay, let's see if we can find that z-score. Okay, let's see if we can find that z-score. So look, y'all, if we wanted to find that z-score, do you guys agree we'd use our inverse norm, right, to find the z-score? The inverse norm will tell me to find the z-score when I know my area, right? So look, 0.88. And y'all, I'm going to take a wild guess and say my z-value is going to be positive here. There it is, 1.17, okay? So our z-value is a 1. What did I say, 17? Yeah, 1.17. Okay. Y'all, since we are looking for the test score, what we want to do now, my friends, what is the x value? Okay. What is the x value? You hear the air? Right? It's getting cooler, isn't it? All right, good. It's never fun when it's all hot. Okay, so y'all, what did we say our average was in this problem? Was it 498? Right, if I come back and look at my problem, yeah, here we go. So look, y'all, here's my numbers, right? So look, our average was a 498. Our z, we just got to be 1.17 times 9.3. Okay, let's take a look here. Let me clear this out. 498 plus 1.17 times 9.3 And let me hit enter. Y'all, I'm coming up with this number here. They are asking me to round to, again, to the nearest integer. Would you guys say a score of 508 or a score of 509? 509, right? Okay. That's what we need to score on the test in order to be considered that or better, right? We could do better, but we got to make a score of 509, if not better than that. Y'all, before I do the last problem, are you guys kind of picking up on the process and what I'm doing here? Okay. Y'all, like I had told you guys, the last time I taught stats in person was the fall of 19. That was right before COVID hit, right? So I hadn't taught it in person in a long time. I taught it online a few times, and when I taught it online, y'all, it was like during the pandemic. So one of the things I used to do with my online classes, like when we were all at home, was I would do these live sessions with them. I'd say, hey, look, you don't have to join, but if you got questions, Thursday at 4:00, boom, I'm going to be online. We can do some stuff. And you know, I'm sure, I don't know if you guys were already in college when COVID hit, or you were in high school or junior high, whatever it happened to be, right? But it was difficult, wasn't it? Because you're at home by yourself. You're trying to figure stuff out, right? You're not in the class with everybody else. So guys, if I'm repeating myself, forgive me. I just want to make sure that you guys are good with this. Okay. So if I'm like, gosh, there's another one like that and the same one, I'm just trying to make sure you guys are good. Okay. And I'd rather overdo it than, sir, we didn't go over this. Yeah. And that's the other thing too, is that I wanted to have the videos. So like for all my other classes, and for this one too, I actually made all the videos when we were at home during COVID. But from that time until now, I'm changing the notes a little bit because I'm trying to make it a little bit more tailored to what you actually see in the homework. So I have old videos, but like this question is not in there, and some other questions are not in there. So I'm trying to make it similar to what you guys are going to see. Okay. All right. Yes, sir.
Very helpful, sir.
Good. Good. So, guys, this is the last question we got of the day. And we are again talking about hippopotami. Okay. So let's take a look. Couple of things, y'all. My average, 268. Standard deviation of 8 days. So, y'all, this is talking about the length of gestation. Anybody know what gestation is? Anybody know? What's gestation? Anybody know what that word is?
It's the period of after conception.
There you go. After conception, before the baby's born, right? So, boom, sperm fertilizes the egg, right? Boom, we got a little life going on inside. And how long does it take for that, in this case, hippopotami to be born? So for hippopotami, guys, the average is 268 days with a standard deviation of 8. Okay, let's see if we can do part A. Part A says, what percentage of hippos have a gestation period of less than 261? So look, y'all, we're looking for the probability that X is smaller than 261. Okay, let's do this. Step number 1, convert it to a z-score. Okay, let's do that. And so we're going to convert it to a z-score. So we're going to say, in this case, 261 minus 268 divided by 8. Okay, 261 minus 268 divided by 8. Y'all, for my z-scores, we always go to 2 decimal points. So I guess I'd put negative 0.88. Okay. All right, again, y'all, just to draw a simple picture so we can see what's going on, we're looking for the area to the left. Friendly reminder, negative 5,000, okay? Negative 0.88. Okay, let's see if we can figure that out. All right, let me clear this. Second vars, Normal CDF, we said my left limit is negative 5,000, comma, our right limit, negative 0.88. Okay, and let's take a look here. Y'all, they are asking me to write this as a percent, and they do want us to go to one decimal place. So y'all, if we were to convert that to a percent, remember all we could do, easiest way to do it, multiply it by 100, right? And look what we got, 18.94. Since they are asking us to go to one decimal place, would you guys say 18.94 or would you say 19? But remember, I do want to have one decimal. So meaning I got to have a point something. Should we round that 9, I guess is my question to you. What do you think? Should we round the 9 or should we leave it alone? What's the number to the right of the 9? It's a 4. So we're going to leave it, y'all, as 18.9. Okay. All right, so we got part A done. Let's take a look at part B. Okay. So y'all, part B is talking about only 6% of hippos will have a gestational period longer than how many days? Okay, so y'all, I want you to think about that part there, okay? They're telling me 6%, okay? But longer. So y'all, when they're talking about 6%, what they're telling me is that the area to the right over here is 0.06, okay? It's in the top 6%. Does anybody know what would the area to the left over here be? How could we find the area to the left? Yeah, 1 minus, right? So let's do that, y'all. 1 minus 0.06, 0.94, right? Okay. So let's see if we can find the z-score that corresponds to that, okay? Let's see if we can find our z-value. So remember, y'all, I'm going to go to my inverse norm, second vars, number 3 inverse norm of a 0.94. So y'all, the z-score that I have is a 1.55, okay? Now, we're looking for how many days. So y'all, if we're looking for the number of days, we're going to convert our z-score to an x value, okay? Let's see if we can do that. So I'm going to zoom out a little bit just so I can see everything here. Okay. So x equals our average, 268, our z-score of 155, times our standard deviation of 8 days, okay? Okay, let's try this. 268 plus 1.55 times 8, okay? So y'all, if we were to do this, and again, this is the number of days, and we want to round this to the nearest integer, would you say 280 or 281 days? 280, right? 280 days, y'all. So for part B, we got 280 days. Okay. Okay. Y'all, we got one last part to do, part C. And let's see if we can figure this out. Part C says the percentage of hippos that have a gestation of less than 226 days, okay? So let's do this, y'all. Let's come back here. We're looking for the percentage of hippos, probability, that are going to have a gestation period of less than 226 days, okay? Y'all, step number 1, let's find our z-score, okay? Because if we find our z-score, then it's easier for us to find that probability, okay? So y'all, my x value here, 226, okay? Y'all, I'm going to zoom back out at the very, very top because I had my average and my standard deviation here, okay? So our average was a 268 divided by our standard deviation, which was 8, okay? So let me grab my calculator, 226 minus, we said 268 was our average, And we're going to divide that by 8. Y'all, look at my z-score, negative 5.25, okay? So y'all, my z-score, negative 5.25. Y'all, I'm going to draw a picture, again, just to give you a visual here. Here's my average, right? Y'all, remember, we're looking for the probability that z is smaller than negative 5.25. We're looking here, and y'all, we're looking for the area all the way to the left, okay? Remember what we said over here, y'all? Negative 5,000, right? Okay, so let's do this to this. Normal CDF, okay, negative 5,000 to a negative 5.25, okay? And let's see if we can figure this thing out, y'all. So look, I'm going to come back here, second bars, number 2, negative 5,000, 1, 2, 3, comma, negative 5.25, okay? All right, here we go. Man, look at that number. Crazy. Is that number big or small? Small. Okay, remember what we're going to do, y'all? We're going to move that decimal 8 spaces that way, 8 spaces to the left. We already got one number to the left. We got the number 7. So y'all, what that would mean is that we would have point 1, 2, 3, 4, 5, 6, 7, and then the number to the left of it was the 7 also, right? That would be our number. As a percent, is that number close to what percent? 0%, right? So boom, right here, guys, you're going to drop in as 0%, right? Why? Because it doesn't look like hippopotami are going to have a gestation period of less than 226 days, right? That's way less compared to the average, right? Okay, y'all, just as a heads up, we've done 5.1, we've done 5.2, we've done 5.3. Thursday, my friends, we're going to do 5.4, okay? It's going to be similar. Y'all, the one thing about Chapter 5, I'm hoping as we're going through, like we've done the Z formula. We've done converting the X value to a Z formula a couple of times. We've done normal CDF a couple of times. Today we did inverse norm a bunch of times, right? Chapter 5, y'all, is very repetitious. There's small changes here and there, but the problems are kind of similar, okay? Y'all, I know we're done with the lecture, but we have some folks from Region 1. I don't know if y'all know what Region 1 is. Region 1 is the educational agency, y'all, that oversees every school district as far west as Laredo and all the way down, y'all, to the Gulf. Brownsville, huh? You worked with Region 1 before. Awesome. They go, huh? Oh, you work for them now. Okay, awesome. Co-workers. Y'all, the 2 women that are here are going to talk to you guys a little bit about financial decisions that are going to impact all of us. And so, guys, I know we're done with the lecture, but if you wouldn't mind just holding off and listening to the things that they got to say, and then, guys, we'll be done. For those of you who are online, I am going to go ahead and stop recording. And guys,